Hi there, on the bench today we have a Baofang UV5R. This is the first of the Baofang models I bought, and what I plan to do today is try and do a power measurement. This one's supposed to be, I think, 5 watts on high power, and also look at the harmonic content of the radio, because there's some suggestion that they're not very well filtered for harmonics. I think I'm just going to do it on 2 meters on 145 megahertz, which I've got it set to at the moment. And not only that, I'm going to do the other one I've got here. This is the GT3TP, also by Baofang, and this one supposedly is the high power one. This is the 8 watt one, but I think they're lying when they said that. The most I've ever seen is 6.5 out of it. But, you know, how accurate is my measuring equipment? That is the point. It's very hard to measure RF power accurately, and I'm measuring it on the spectrum analyzer, which will read in dBm or volts or whatever, or watts. And in order to do that, of course, I can't just connect the radio straight to the input of the spectrum analyzer, because if I transmit it into the input of my spectrum analyzer, that would be the end of my spectrum analyzer, and I'd have to bury it in the garden, sadly. It does say it's got a maximum input of let me see, over there, plus 30 dBm, which of course is a watt, but I wouldn't even like to put a watt into it. I think the most I would put into that would be about plus 20 dBm to be on the safe side. So what I'm using is this big black thing, which is my power attenuator. So this is a 30 dB power attenuator, and it's more or less flat right up to 2 gigahertz. So that's how I will be testing the Baeofangs. So if I stick 1 watt in the input to the attenuator, I'll get 1 milliwatt out the other end. That's the general idea anyway. And 10 watts would give me 10 dBm, because 10 watts would be 40 dBm, and take 30 away is 10 dBm, which is more than enough safety margin for the spectrum analyzer. So I'll go ahead and wire up the UV5R first of all, and do some measurements on that one. Right, UV5R is connected up, and it's set to transmit on 145 megahertz. So let's go ahead and press the PTT, and there you are. You can see the peak. If I do peak search, I've actually got it set into watt mode at the moment. I'm going to measure the wattage first of all, and that's a fairly good result, I think. That's 5.65 watts. And by the way, I charged both the batteries before I did this test, so that would be the peak output you would get on the radio. So what I want to do now is look at some of the harmonics. You can see them there. That'll be the second harmonic, third harmonic, fourth harmonic, and see how far down they are. And in order to do that, I'll have to go back into dBm mode, so I'll just go ahead and do that. Right, now I'm ready to do the harmonic measurements. So I'll transmit again and do a peak search, and I'm reading 37.5 dBm, which is equivalent to 6 and whatever it was watts. So if I do what should I do? Delta marker. Let's do delta marker, and we can go across. You can see the little thing on the bottom moving around, and this will just give you the difference in frequency and in dBs between the last reading, which is the reference reading, that is, which is still on 145. So if I go on to the second harmonic, we're getting 58 dB below the fundamental. I think I need to write that down somewhere. I'm never quite prepared for all this. So you know me bloody penned out, bloody work, as is normal. So UV5R, 5R, what are we talking about? Second harmonic, and third. I'm just writing all the third and fourth. Right, so second harmonics, say minus 57 dB down. Now we go to the third harmonic, which is obviously the worst one, and that is minus 50 dB down. And the last one is the fourth harmonic. Of course it is, because the carrier is the first harmonic. And that was minus 53, minus 54. So here we are then. We've discovered that the third harmonic is the worst offender. Now what we can do is go back to that one and change over once I've got on top of that one. Now what I'll do is stop transmitting and I'll go back into amplitude setup and we'll measure the actual power in watts. So I've changed from dBm over to watts and have another transmit, and I'm pressing the wrong buttons. Reference level 10. Yeah, okay, fine. Marker again. What's it doing there? What's it doing there? Oh, of course I'm still in delta marker, normal marker. That's what I want, normal marker. Right, just try and get it right on the peak of that. And it would help to get maybe a bit of averaging on this. It's averaging 5 enter. Right, that makes it a bit less jumpy. So marker again. Try and get on the peak. So we're reading maximum of 50 microwatts. I'll write that down. 50 microwatts on 435 megahertz. Well, that's in the amateur band anyway, so that's not going to cause any real problems to anybody else, like other services outside of that. So let's look at the second harmonic, and that one's 11 microwatts. Well, it's not much of a signal, is it? That's not going to cause too much trouble. It might do if you had it on a big outside aerial, but on the little whip it's got on top of the radio, I don't think that's going to cause a problem. And lastly, we'll look at the last one on the other side. So the last one, the fourth harmonic, and that is 30 microwatts on 579. Now that's in the TV band, and that might cause trouble if you were close to somebody's TV aerial. That might cause it to block out their TV signal. But I think the problem is Baeofangs just can't do the filtering very well because of the fact it's such a broadband radio. And I'll stop transmitting now. I mean, in the old days of a dedicated 2 meters and 70 centimeter amateur radio by Kenwood or whatever, they'd probably have a band pass filter instead of high pass. So, but with Baeofangs, they're covering a massive frequency range on VHF, all the way from 136, is it, up to 174-ish. So they've got to be, they can't filter anything in that band. But I'm waffling a bit and I'm not sure what the hell I'm talking about either. So I think the next job is just to go back to the, go and try the other one, the GT3TP, which is the higher power version, and see how that works out. So that's what I'll do next, set that one up. Right, now I've wired up the GT3TP, that's its number. Well, I'll go to transmit, and remember it's on averaging, so it's going to take a while to settle. And do a peak search, 6.58 volts, so they were lying, and it's not 8 watts, but I never really thought it would be. But it's still, you know, fairly good output for a little radio that size. And I think back to my first handheld, it only had 1.5 watts output, and it was nearly 3 times as big as this Baofang. Anyway, let's look at the harmonics. So if I go back into amplitude and change back into dBm rather than watts, and do peak again, that's 38 dBm. Now marker, and we'll do delta marker. So we're looking at now the second harmonic, which is on 1/4. Yeah, that's 145 away, obviously, from the fundamental. So that's minus 49. Minus 49 dBs down on the fundamental. And interesting. Anyway, let's go on to the third harmonic. That's also minus 49 on 291 megahertz. And fourth harmonic, minus 56. So yeah, let's just go back to amplitude again and go back into watts and marker, normal marker. So that fourth harmonic is 12 microwatts on 582 megahertz. Again, that might cause trouble on TV band. If we go back to the third harmonic, which is in the amateur band, 70 centimeters, we got 84 microwatts. That's a fair bit of signal, actually. 84 microwatts could cause trouble if you were close to another amateur, I guess, or if you stuffed it into the radio into a big collinear. And let's go down to the second harmonic. That's on 291. That's for 50 microwatts. I don't know who uses 291. I think it's Tetra, emergency services Tetra. So again, I suppose it could cause slight trouble at 50 microwatt output if you were close to a policeman using his Tetra radio. But I think with the inefficiencies of most of the antennas on these radios, I don't think you would cause too much trouble. But yeah, it might just be interesting to see what the rest of the harmonics going up the band are like. I don't think they'll be too bad. So if I put the stop frequency at, say, 1 gigahertz, right? Yeah. Well, as you can see, there's virtually nothing after that fourth harmonic. Absolutely nothing, really. Of course, I can't really go down too low on the dynamic range of the analyzer isn't that great, because I'd overload if I try to get myself more sensitivity down here. And the only way to do that is to no, I can't think. But anyway, no, I think that's all there is, really. There's no real major problems after the fourth harmonic. And so what was I measuring on that one? The worst one was 80 microwatts. 80 microwatts on 436. Okay, well that's about the end of the test. I could do a quick test on 70 centimeters and the harmonics on 70 centimeters. Yeah, I could do that. I'll set it up on 433 or something like that. Okay, I've reconfigured the UV5R to be on 433 megahertz. Yep, that's it. So if I go into transmit, remember it's averaging a bit, so it takes a while to settle. And I'm reading, once it settles, 4.77 watts. 4.77 watts. Okay, well that's not too bad, I guess. And let's look at the harmonics then. So I have to go back into amplitude now to go back into dBm and marker, and then do a delta marker. So second harmonic minus 56. Well, that's considerably better than its no, it's not actually. On the 2 meters the second harmonic was minus 57. So this, well, it's more or less the same then, isn't it, on its second harmonic. And third harmonic minus 48. Well, that's the worst result so far. That's on 865 megahertz. Now on 865 you've got these days 4G, I think, mobile phone. So what does that represent in power terms? So I'll go back to amplitude, units, watts, and peak. Marker has got to be back to normal, and marker second harmonic is 10 microwatts, bugger all really. Third harmonic on the UV5R 70 microwatts. Yeah, I could see that would, right, okay, that's on 1296. Well, of course it is. Yeah, that's the amateur band as well. So yeah, so it's 71 microwatts on the amateur band. I suppose it could cause problems to a radio amateur who was using that particular part of the band. So 70 microwatts. Yeah, okay. Well, I'm going to go ahead and do the same test on the what's it called, GT3TP. Okay, this is the GT3TP, 8 watts output, 6.5 more like, but not too bad all the same. And now I need to check its harmonics, and to do that I have to go back into amplitude, units into dBm, and marker, delta, and that is minus 50 dB down on the carrier, minus 50 dBs at the second harmonic. That's the worst harmonic by the looks of it. I mean, I've seen radios with minus 60 dBs down on the second harmonic, so I guess that's fairly poor compared to some. And the third harmonic is minuscule, that is minus 55, minus 56, and as far as I can see there's no other harmonics visible all the way up to 2 gigahertz. So we'll just do a quick measurement of the power amplitude, units, watts, marker. So that one is on 1296 with 15 microwatts. As I said before, that might cause slight trouble on the 23 centimeter band, but I can't really see it being a problem. And going down to the worst one, second harmonic, I could just do peak for that. No, I can't. No, I can't. I'm getting 80 microwatts on 866. That's again in the Tetra bands, so that might cause problems with some people's mobile phones. But yeah, I think it's pretty unlikely. But that's just the way it is, I guess. And interesting little test all the same. And they're good radios for what they are, and when they're used with their fairly short whips, I don't think you're going to cause too much trouble to too many people. The worst problems you have got these days, I stopped transmitting, is if you transmit on 70 centimeters, it completely blocks people's key fobs, because in this country, for some stupid reason, they've stuck the radio key fobs on 433.9ish, and so even on low power and quite a few hundred feet away from a car, you can completely block people's key fobs. In fact, there was a story of a repeater in Bristol that had to turn off their transmitter when people were having problems getting into their cars. Don't quite know how they managed to do that, but in the end the repeater, I think, had to move. I think it was on top of a hospital with a car park nearby, and it was causing trouble with people not being able to get in their cars because of the stupid frequency they put the key fobs on. And anyway, that repeater's now moved, so they haven't got that problem anymore. But whose stupid idea was it to stick all these low power devices on a part of the frequency spectrum where radio amateurs are licensed to run up to 400 watts in this country? Anyway, that's the state of the radio authorities who design all this rubbish. So anyway, that's, I think, is the end of the video. Fairly interesting results, I think, and bye for now.